Alright gang, welcome back. This is video 3, which is about the Pythagorean Theorem and the distance formula, which are essentially the same exact thing, just in different context. Again, review, so this should go pretty smooth for you. I want you to remember that the Pythagorean Theorem is used to find the missing side of a right triangle, if you already know what two of them are. It only works for right triangles. And you may recall the actual theorem, a squared plus b squared equals c squared. Pretty simple thing. The only thing I want to remind you is that the c has to be the hypotenuse, the side that's across from the 90-degree angle. The a and the b doesn't matter, as long as the c is the hypotenuse. I would also like to refresh your memory on something that we covered in geometry class, which is the Pythagorean triples. And the only reason that I'm bringing these up is because when it comes down to it, if you know what your triples are, it's a time saver in a lot of cases. You don't have to use your calculator because you know about the 3, 4, 5, 5, 12, 13, 7, 24, 25, the 8, 15, 17. There are more, but those are the more significant ones. And also remember any multiples of those. So instead of a 3, 4, 5, if you have a 15, 20, 25, that also works. It's a 5 times a 3, 4, 5. So let's get some practice in on figuring out the missing side of a right triangle. And I want you guys to discern between having it in simple stratical form, SRF, and rounded to the nearest hundredth. Sometimes they're going to ask you for one versus the other, so make sure you're paying attention to that. So here we have a triangle with two sides, 14 and 28. And so what you need to pay attention to is, what sides are they? Are they the A and the B or something else? Well, the C has to be the hypotenuse, so go ahead and throw the ABC in there. Again, the A and the B, doesn't matter. And then just use the formula. A squared plus b squared equals c squared. 14 squared plus b squared equals 28 squared. All right, from there, we're going to end up taking 28 squared minus 14 squared. We get 588. Okay, so far, this is the way you handle all of your problems. Now we're going to separate into two different thought processes. One, I'm going to get it in simple stratical form. And two, I'm going to get it as a decimal. So what goes into 588? 196 does, in case you didn't know, 3 times. Square root of 196 is 14. So 14 square root of 3 is our answer in simple stratical form. All right? Rather than actually crunching out 14 times the square root of 3 on your calculator, if you just back on this step, if you just take the square root of 588, that's going to give you your answer to the nearest hundredth. So hopefully all of this is coming back to you. Yes, in simple stratical form, it's 14 square root of 3, and to 100, it's 24.25. Okay, the distance formula is essentially just the Pythagorean theorem, but with coordinates. Okay, the example that I just showed you was a triangle, and it had side lengths on it. Well, what if you just have 2 points that are on a graph? You'd use the distance formula. And that is the Pythagorean theorem, but using coordinates instead of actual lengths. And you may remember, the formula looks a little something like this. Okay, it's long, but it's not as difficult as it looks. This is your change in x. This is your change in y. So if you have a point right there and a point right there on your coordinate system, this is your change in y, this is your change in x, and you're looking for the distance between them. So you're using the Pythagorean theorem. Now, those of you who are in my actual classes may remember another thing that we did, which was referred to as the bow tie. bow tie method of finding the distance between 2 points. That's what I prefer rather than that lengthy equation. And for those of you who are not in class, I'll show you what I mean. First, I'm going to do it with the distance formula that we just used. Let's say that we have two coordinates, 4, 1 and negative 2, 3. Now, in actuality, it doesn't matter which one you decide is 0.1 and 0.2. It's all going to come out in the end because of the squaring. But in this one, I used 4, 1 as my first coordinate and negative 2, 3 as my second. So the distance formula will be the negative 2 minus 4 for your x's, and 3 minus 1 for your y's. Negative 2 minus 4 is negative 6. 3 minus 1 is 2. And this is what I meant. It all comes out in the end because of that squaring. So you're not going to end up with negatives underneath the radical. 36 and 4 is 40. The simplest radical form distance is 2 squared 10. But to the nearest hundredth is 6.32. Alright, so what is that bow tie method that I was explaining a second ago? It's no different than the distance formula, but you don't have to write it out with the radical and all that other stuff. You just find the distance, or think of a number line. How far apart are 4 and negative 2? They're 6 units apart. How far apart are 1 and 3? 2 units apart. Square them, add them, and square root it. That's the infamous bow tie method. And once again, pay attention to whether or not they're asking you for your answer in simplest radical form or to the nearest 100th. That is the Pythagorean theorem and the distance formula. Adios.